Hello everyone, my name is Nathan and today it's time for another episode of LogicBots. After the first episode, you guys, of course, gave me some awesome tips in the comment section that allow me to gradually improve my designs here. So the way I was approaching it in the first episode was way too overthought. I was going way too complicated. Let me actually show you what we got right now. So I have several builds here. For instance, we have a budget build, only using one single sensor. Let's actually have a look at that. You can see the sensor is dead center. I could actually have left out this bar, but you know, it's cool there. If we have a look at the circuit board, you can see we are using tremendously fewer circuits. The way this works now is with this only sensor, it outputs a signal into a NOT gate in order to enable the left motor and then directly enable the right motor. What does that exactly do? Well, of course it's only gonna run on one wheel the entire time, and it might at some points be a little bit wobbly, but basically it attempts to stick at the edge of the line because that's where both sensors should be focusing on. Let's actually have a look at that outcome. So there we go, we can see that it is exactly on the edge of the line and only one wheel. They are alternating very quickly with each other. So with this we are actually within budget. We are extremely slow still, but this is the cheapest possible design. There is a better design. Let's have a look at another save. I do have a fast build as well, so let's go ahead and load this one up. Here you can see we have two sensors. They are spaced apart a little bit, and if I wanted to do it a little bit more extreme, I could even angle them a little bit towards the outside, so they are pointing more or less forwards into a diagonal direction. Also, you can see I slanted the wheels a little bit. For some reason this made the design actually a little bit faster. So let's test this one out. And you can see this time both of the wheels are actually going. I'm going to show the circuit in just a second. I totally forgot about that. And this one here is functioning by trying to keep the line in the center of the vehicle. And there we go. So if we speed this up, this should actually make it to the goal in time. I'm not so sure. The last time I think I reached it. Yeah, there we go. We made it 5 seconds early actually, and therefore we got also this medal. Let's check out the circuit for this one because it's a little bit more complicated. What we have here is the left sensor going into a NOT gate enabling the left motor, but at the same time it's also enabling the right motor, and the same thing with the right sensor. It first of all enables a NOT gate going into the right motor and then also directly enabling the left motor. And this way we're trying to keep the line always centered as good as possible. So that's that about this design. Now I actually got the ultimate design as well, because there was a task to do it without circuitry, and I was thinking, what? How is this possible? And it is actually possible with the ultimate build right there. Let's load this bad boy up. Right here you can see we are using two sensors in the center more or less. I also got the slanted wheels and everything else is normal. Let's have a look at the circuitry. Right here you can see there is none. Now that's why I really overthought the previous design, but this thing is actually gonna solve everything, all the medals in one go. The left sensor is hooked up to the right motor and the right sensor is hooked up to the left motor. So let's actually see how this behaves. We can see it is attempting to always remain inside. So both of the sensors are detecting the line, and as soon as one sensor goes over the line, then another wheel will shut off. And there we have it, you know, without any circuitry at all. This is the extreme budget build. I think that was 375 instead of 450. So if we let this run and go, we should also be reaching the goal within the 1 minute and 15 seconds. Let's see if that works out. And yes indeed, it was even a little bit faster than before. And look at that, all the medals at once. That's extremely cool. Now let's go ahead and have a look at the second level. So right now we are working with the ultimate build. This is the build that solved everything the previous time. We can see we have no circuitry. However, this time we're probably gonna run into issues because of a 90 degrees bend. And yeah, look at that. We went outside the line and therefore none of the motors is going at it anymore. So we kind of have to invert that. We need to make sure that the motors are always running except certain conditions are true. Let's go ahead and do that. First of all, let's remove both of these things. What we're going to need is a dual switch. I'm gonna place that right here, and I'm also going to need, I think, a NOT gate. Yeah. So first things first, as I said, we always want the left motor and the right motor to be turned on. So we're gonna hook up these two things right there. This will enable the motors the entire time except when certain conditions are true, and that is if the left sensor isn't working at the moment, then we want the left motor direction to turn around. And if the right sensor is working, then we want the right motor direction to turn around. And this way we can take tighter bends, because the right wheel, for instance, is going to turn into a clockwise direction while the left wheel is turning into a clockwise direction. And that is obviously going to turn around the thing much faster. You would use that principle with a wheelchair, for instance. You would use both wheels to take tighter turns. So let's test this out. We're going to hit the start button, and this time we can see we are at the edge of the line once again, but we will be able to follow it much more precisely. Let's see if that actually also happens with the next turn, which is very important because of course we need to be able to take turns into both directions, and since the line has a certain thickness, it's sometimes very finicky. But this time this seems to be working out. Let's see how it deals with the tightest bend right there, and oh yeah, that's what I'm talking about. No problem at all. Now with this design, I don't think we are necessarily going to reach the goal within 1 minute and 8 seconds. Oh, that was really close, just 4 seconds late. But we are within budget and we were able to complete the level. So let's continue and go actually into a more fishy terrain. Now this design is the same we used before, so I have the same circuitry installed as well, and this should actually also work for this level. I think I already tested this out. This time we have sharp bends, 90-degree angles, and this design also seems to work in this scenario. So let's see this happen. Yeah, turning around, and then we got this one. Oh, it's a beauty. It's a freaking sheer beauty. Let's speed this up a little bit and see how long it takes us. Oh guys, we're programming robots. I don't believe it. Okay, one more turn. There we go. Yeah, we are way too late. No, actually not way. It's 10 seconds or so, but still, that's way too much. So maybe you guys have suggestions on how to do this better. But in the meantime, I think we should continue with the next puzzles. For instance, the dashed line right there. So using the same design, I think this is still the same. No, this is actually a completely different design. So let's actually test this out. And oh yeah, look at that, a dashed line. Of course, in this case, we have to make sure we are also driving when none of the sensors is detecting anything. So that is a little bit finicky, and I think this design fails at a point because it takes 2 sharp turns right there, and of course that's not good. We will be driving straight at a certain point. Maybe let's speed it up. Yeah, it already happened. So what we have to do is maybe build a sensor in the center and then some sensors on the outside that are a little bit further. Or maybe the sensor in the center isn't even necessary. We should actually see if we can, for instance, do it with the fast build. This might be possible. Yeah, with the sensors a little bit on the outside. Let's test this out. Let's see how it behaves. Okay, looking good so far. I think that is gonna give us a little bit more flexibility as we turn around, or should turn around, but they still might be too close together, the sensors. Yeah, it's not extremely precise. Oh, but it's looking good, guys. I mean, we were able to take the first turn already with one of the robots we designed, so maybe we don't even have to go for another one, except of course we want to get all the medals, but I do want to unlock more parts first. I feel like we are missing the XOR gate, for instance. That would be useful. I feel like at the sharp bends, it's going to fail eventually. Alright, we're taking a little left turn. Come on. Ooh, that was close. That was really close. I don't think this is gonna work out. Oh, turn. Oh, baby. Oh, you're magnificent. But that is the recipe for those guys. We have... okay, maybe it still works. We can take a little, shortcut here. Okay, it actually did work. And we made it within budget, so I'm really surprised about that. So what I think we should have to make this more secure is put these guys a little bit further to the front, and I think the distance between them is actually fine. But yeah, that was that. Let's see what the next puzzle is. The next puzzle is a platform. Oh, that could be interesting. Let's actually have a look at the objectives and view the level. Oh yeah, I love it. I love it. So the platform is basically one thick line. So that means as soon as our robot doesn't detect it anymore, then it should take a certain turn. So that is absolutely magnificent. Let's go ahead and load up a robot that brings us close to what we need. Oh, those guys are unavailable. Okay, we have to use a different kind of robot today. That is great. A different kind of main body, the spider body here. Wow. And let's see if we can add a couple of lines here, snap lines. I'm gonna mirror the snap lines for the wheels. We're gonna have 4 wheels on the outside. And we're gonna add one more snap line at 90 degrees for the horizontal line. Let's add a couple of these pneumatic wheels. Unfortunately, we still only have those guys, though they do not seem to be working for this design. What do I have to use? Okay, we can actually add a wheel right there. This makes so much more sense. Okay, let's try this again. We're going to add a wheel right there, and now it's actually also hooked up to the motor. I'm so glad. So this should be right motor clockwise, and then we should also have the left motor anti-clockwise. Beautiful. But this is not going to be very balanced, is it? We're going to add a line right there and add a couple of caster wheels. Or maybe we should go with the other types, like the caster ball. I mean, this is a funny little thing, I think, yeah. I think at the back I'm gonna add the other type of wheel because I think this one is larger and therefore it will always have the tendency to drop forwards. We're going to add an extension, something along these lines, but this time it's going to be quite long, maybe not that long. We might want to go with 1 meter or so. Good, now I'm gonna need some horizontal snap lines. For the sensors, they need to be, you know, far apart from each other, so my vehicle can react accordingly, and we got the sensor there. Oh, this looks like a different type of sensor. Ah, I can put it on the block below here, actually. Yeah, this is gonna work out. Just pointing down. Interesting. Now, of course, we shall not forget to actually rename those guys. This is the right laser, and we also got the left laser. There we go. Okay, time to have a look into the circuit board. This should at least work more or less. We're gonna add the left laser up there and then the right laser. So once again, whenever we don't detect anything on them, for instance, we don't detect anything on the left laser, then we want the left wheel to turn off. No, the other way around. We want the right wheel to turn off. So let's add a couple of splitters. And look at that, we finally get the number monitor and the clamp. This is something I haven't seen in the tutorial. Rounds an input number to the nearest whole number. Wow, this is amazing. Oh, I cannot wait for all the math to actually come up in this game. But let's not go crazy. Let's try to remain simple. This is still only the introduction to the game, more or less. So let me think about this quickly. It's kind of hard to get the thoughts straight while having to commentate over it. Alright guys, I think I got a nifty solution. Now, one thing I didn't understand at first is that this sensor is completely different. This actually measures a distance and gives out something numerical. So we gotta compare a couple of values, etc., and that's actually quite interesting. So I decided to go with a similar concept we had in the first puzzle, namely 2 sensors, one being outside of the line and one being inside of the line. So if we start up this vessel, nothing is gonna happen, but you can see one of the sensors is just outside of the detection area for the ramp and the other one is on top of it, and that's what I always want to keep. And I also decided to do it on the right side because we don't have an extremely sharp corner on the right side, we only have one on the left side. So let's go ahead and take care of the circuitry, right? We already got our sensors right here. What we now need is an actual number monitor so that we can see what the sensors are outputting at the moment. So both of them are outputting a range of 1.127 meters. Now, if we have a look at that, this is actually all the way down to the floor. You can see it actually doesn't hit the desk anymore. Now, in order to figure out what the distance is to the bottom actually, What I did is I placed another sensor somewhere along these lines, maybe here at the bottom, just to see how far this is. This is about 0.3 meters, so I decided to go with that value. That should be good enough, but I kind of needed to get an idea of the distances. So with that knowledge, we're also going to set up a static value of 0.3 and 0.3. However, we're going to treat those two signals differently. One we're going to check for bigger than, and the other one we're going to check for less than. So let's add that here and there. The left sensor is actually on top of the ramp, so that means we want to check if the measured distance is below 0.3 meters. So let's take that value from the left sensor. If it is less than 0.3, then we want to give out a signal. So at the moment that isn't the case. Same thing with the right sensor, but vice versa. If the right sensor is above 0.3, then that means we want to have it turned on. And by it, obviously, I mean the motor. So let's actually hook these guys up. This one is going to go to the right motor and this one to the left motor. So essentially, this should always keep the two sensors in line, one being outside the area and one being on top of the area. Let's actually test this out. And yeah, there we go. It's still a little bit wobbly and everything, but it does its purpose so far. It is following the line, trying to keep one sensor on top and the other one outside. Oh, that is great. It is a fabulous... We are actually also pretty fast, I would say. I'm not sure what the goal here is, but we did beat the time. Cool, cool, cool. Parts used 8, gates 4. The costs are still too high. I wonder what is the extra challenge. Let's check this out. The extra challenge is complete without using any static value. Oh, that is cool. That's something we could achieve, you know, using mathematical functions and just using the outputs, the numbers that we have right here. I don't think that would be too complicated, but we can come back to these puzzles later on. For now, I just want to do a little bit of progression and see where it goes. Maybe let's already have a sneak peek at the next level. Holy cow. We're using a new type of sensor in this case. This is gonna be so cool, so interesting. Now we actually have to make it through a little corridor here and detect the walls and act accordingly. This is great. Oh, guys. But anyways, at this point we have to stop for the second episode. I sure hope you enjoyed it, and I sure hope you're going to join me in the next one when we solve this corridor puzzle. With that out of the way, don't forget to leave me optimization suggestions, I'm always glad about those. And also leave a like down below when you're already at it. With that out of the way, have a great time, and hopefully I'm going to catch you in the next video. Bye bye.